Independent educational content. Views and opinions are entirely my own and do not reflect the official policies or positions of Akamai Technologies. Welcome to this explainer. Today we're diving deep into the architecture of serverless edge computing, and we're zeroing in on Akamai EdgeKV. Look, if you're a system architect, a DevOps engineer, or developer trying to build those ultra-low latency apps, you already know the drill. Managing data at scale is incredibly tough. It's basically the final boss of modern web architecture. So we're going to unpack exactly how distributed key-value stores function at the edge to solve this massive challenge. Just to reiterate the quote we're looking at here, this is a purely independent analysis. Our goal today is to totally strip away the marketing jargon. We want to get under the hood and look at the raw, unfiltered mechanics of how this technology actually works in the real world.
Here's our roadmap for the explainer. We'll start with the latency bottleneck, then define what EdgeKV actually is, check out the architecture and consistency model, and wrap up with the primary benefits for developers. Simple as that.
All right, kicking things off with Section 1, the latency bottleneck and the real challenges we face with data in motion.
Take a look at the stark contrast between the old-school centralized cloud and a modern edge network. As web experiences get hyper-personalized, think about instant shopping cart updates or real-time gaming leaderboards. The sheer volume of data we generate is just staggering. Today's applications absolutely demand millisecond-quick decisions. If your app has to travel thousands of miles back to some centralized server or distant cloud just to fetch a tiny piece of information, well, your latency spikes and your functions drag. To process this data in motion efficiently, the data literally has to live right where the user is interacting with the app.
Which brings us right to Section 2. What is Akamai EdgeKV? Let's zoom in on serverless data.
Put simply, EdgeKV is Akamai's distributed key-value store. You can just think of it as serverless data. It basically gives JavaScript developers the power to build incredibly fast, data-driven applications by putting their database right next to their application code, right out at the edge. By doing this, EdgeKV completely eliminates that dreaded, slow round trip to a distant cloud or an on-prem server. The data just sits there, waiting and ready to be queried instantly, and you don't have to manage a single piece of underlying infrastructure.
Now, EdgeKV doesn't just exist in a vacuum, right? It's built squarely on top of Akamai EdgeWorkers. Akamai has deployed these JavaScript engines across hundreds of thousands of distributed servers all over the globe, which creates this massive, incredibly dense edge compute network. So when you pair the compute logic of EdgeWorkers with the data store of EdgeKV, you're combining lightning-fast logic execution with rapid data access. And all of this is happening right next to the user, literally anywhere on Earth. Moving along to Section 3. Architecture and consistency. Let's look at exactly how EdgeKV functions behind the scenes.
So here's the million-dollar question. How does a globally dispersed database stay synced up without lagging out? Well, it relies on a highly efficient eventual consistency loop. The golden rule of EdgeKV is this: read locally, write globally. You write your data, and it distributes globally across the entire network within about 10 seconds. Once it's distributed, your app reads it locally from the absolute closest edge server with virtually zero latency. It's such an elegant fix to that data in motion problem we talked about because your app is never stuck waiting on a centralized server to greenlight a read request.
Okay, theory is great and all, but let's actually open up the developer toolkit. Let's look at the real-world product capabilities system architects are using to make this happen.
To really leverage EdgeKV, you need robust tooling. We just talked about the 10-second eventual consistency, but check out the integration stack here. Akamai gives you a JavaScript helper library so you can seamlessly drop data operations directly inside your EdgeWorkers code. Super clean. If you need to manage database functions externally, they've got a fully featured administrative API plus a command line interface for your day-to-day operations without having to write any custom API code. And, absolutely crucial for security, it includes tokenized access control that lets you strictly enforce who or what is allowed to query your databases. It's really a comprehensive suite built from the ground up for agile development.
All right, final section, Section 4, primary developer benefits. I like to call this the just code motif. The real beauty of these as-a-service ergonomics is that they completely abstract away traditional database administration. You absolutely do not need to be a DBA to use this. You don't need to stress about scaling or failovers because the distributed architecture inherently handles resilience for you. You can invoke database functions with literally just 1 or 2 lines of code, and you can store strings, arrays, lists, or even deeply nested JSON without being chained to some rigid schema. The entire focus here, just writing your application logic and letting the edge handle the rest.
For decades, the database has been this massive, heavy anchor holding back truly instantaneous global applications. But with tools like Akamai EdgeKV, that latency bottleneck is effectively a thing of the past. Data and logic finally live together right next to the user. So with these old limitations finally out of the way, I'll leave you with this question. How will you leverage serverless data to innovate and build your next edge-native application? Thanks so much for joining me on this explainer, and I'll catch you next time.